Okay, so we're going to keep going. On some of these problems, it's going to specifically tell you to use your calculator. Some of them it won't. But, like for instance, on this problem, the fourth root of 12, it's going to tell you to use your calculator and round to the nearest hundredth position, because this is not going to come out as a nice, beautiful number. So again, let's go to our calculator. Because this is the fourth root of 12, we have to tell the calculator what root we're doing first. So our index is 4, and then we choose math, number 5 for any root, 12. So that tells your calculator now do the fourth root of 12, and it gives us this number. So if we round to the nearest hundredth, that would be 1.86. So I'm going to write that on my paper here, just by looking at the calculator there. Now, let's go to this one. Here we have this problem that says the cube root of 5 cubed. Now remember that if a square root undoes a square, then a cube root undoes a cube, a fourth root undoes a fourth power, fifth root undoes a fifth power. These are all the same concept and idea. They are just forward and backwards operations from each other, which means that they undo each other. So literally, the cube root and the cube undo each other, and we just have what is underneath that radical, or the radicand, left, 5, which is 5. And we should also be able to see that on our calculator. If we were to do the cube root, which remember is under math, number 4 is the cube root, and then we were to do 5 raised to the third power, that's exactly what that is, the cube root of 5 cubed. It should give us that our answer is 5. Absolutely. Now the only problem is that this is not going to help us out too much whenever we work with problems that are not plain numbers. So like, for instance, in this case, we have one that says the ninth root of x minus 3 to the ninth. But if we understand that these are opposite operations of each other, a ninth power undoes a ninth root, then we're left with x minus 3 as our answer. And again, if a fourth power undoes a fourth root, because they're opposite operations, then we're just left with a 3p plus 1. Now, one of these answers is correct as is. The other one needs something else. Do you remember your rules about even and odd roots? If we have an even root, we have to ensure that it's positive by using absolute value bars, because all of our even roots must be positive. Odd roots, it's okay to be negative, so we don't have to do anything to them. But always double check, if you are taking an even root, it must have absolute value, just to ensure that that's positive.